Hey guys, what's up? My name is Ben Morgan, and in this tutorial, I'm going to teach you the basics of how to make fluid in Blender. I'm going to teach you everything from the inflow object to the collision object to setting up the domain with proper settings and making what are called tracer particles, and finally I'll take you through the rendering process. Okay, so let's get started. The first thing to note when you're doing your fluid simulation is that your object, all your fluid happens inside of a cube, which is called the domain. And this domain will collide with the fluid. So you have to take into account the fact that if you want your simulation to look realistic, either A, you're going to have to make your objects inside of it very small, or B, you're going to have to scale up your domain. Either way, it proves to be a difficult task to keep the water off the walls of the domain, but we'll get more into that later. But first, we're just going to set up our basic scene. So what we're first going to do is drag our default cube up, hold Control, and have it snap to the grid. So it's resting on the floor right now. Next, you're going to tap into Edit Mode, press A, right-click one of these vertices, and do Shift-S, cursor to selected. And that will put our 3D cursor right on the corner of this. And why do we do that? Why? So that we can add in a cube, Shift-A, add cube, and then if we go into front view, by pressing numpad 1 and then orthographic view, we can scale our cube down and move it directly into the corner. And it's just a little easier to do it that way. Okay, so this cube is going to be our inflow. And basically, the water is going to go like this. It's going to bounce off the walls of the cube, and it's going to go into it like this and fill up. Okay, so let's get started on how to go about doing that. The first thing we should do is make our cube the domain for the water. So right click your cube and select in the physics tab over here, right here, enable fluid and make the type domain. And if you've done any fluid simulations before, you might have made the mistake of baking the fluid to what's called the cache, the temp, or baking the cache to your temp folder, which is the base, what do you call it? The default place for your fluid to be made. If you've been using Blender for a while, I highly suggest going to this location on your computer. You can actually just copy and paste it into your Windows Explorer browser, but I really suggest you go to that folder and see how big your temp is, because I'm sure a lot of them will be caches from Blender for either smoke sims or fluid sims, and I know that when I first started using Blender a couple years ago, I hadn't deleted the files in my cache for probably 6 months, and I was doing these really high resolution fluid sims, and I had probably 6-7 gigabytes of data in that one folder. So I really recommend you go and check out and delete those temporary files if you don't need them. Okay, but enough of that. We now have our domain set up, but before you do anything, there are a couple things you need to do. You need to save the file. I'll save it as fluid tutorial. Okay, you have to save the file because 1, your file will probably crash, and 2, you need to have your file saved to bake it. Well, you don't, but it's really recommended because, like I just said, if you're doing really high resolutions, you're probably going to crash. And yeah, so let me just explain before we go into the inflow at all. Let me just explain what some of these settings in the domain do. So bake is basically it renders out the fluid. and this is what gives you all of your big files. So it'll say right here, required memory 27 megabytes. So it's going to take right now at a resolution of 65, 27 megs to bake out. And that's actually, this is basically the lowest resolution you can do it. 27 megs might seem like a lot, but it's really not. Be warned that you're going to be dealing with gigabyte size files if you want to do any high resolution fluid sims or any other sim for that matter. But the cool thing about it is that most simulations you don't really revisit to render, so you can bake it once, you can render it once, and once you get a couple good renders of it, you can delete the files and you don't have to deal with getting a new hard drive or something like that. So that's good. And so obviously the resolution, the final resolution is how good your fluid will look when rendered, and the preview is what you'll see here in the viewport. I recommend putting your preview up to something like 65, and your final resolution, if you want something good looking, you're going to have to get into the upper 150s, 180s, 200s. But if you have a bad computer, or not a bad computer, but if your computer isn't, I wouldn't really call it bad, because you have to have a really, really good computer to render something like this quickly. It might take you overnight, it might take you some of the morning. It'll take probably 10 hours to bake a resolution of, say, 250, all of the frames. So it will take a while, and it will take a lot of memory, so just be warned. Next we have this time. So basically, this is how many seconds in real life the simulation is. So right now, 250 seconds, which is at 25 frames per second, about 10 seconds. Okay, right now 10 seconds in our animation is representing 4 seconds of real time. So basically all that means is that it's going to look very, very slow motion, and you're going to get, you know, a lot more detail that way. The lower you put it, the slower it will look. It's basically how a slow motion camera works, or how you would film slow motion photography. You would film less time over more time, if that makes sense. You will film 2 seconds in 20 seconds. So, yeah. Okay. Next we have the fluid world. I don't really mess with this that much, but you should look at this right here, real world size. If you're looking to do something realistic, you're going to want to change this so that, say, I'm making a coffee cup. My coffee cup isn't half a meter wide, so I'm going to have to resize that to something that would match the real world size so that my simulation will be realistic. Because in Blender, one of these squares right here, one Blender unit is actually 1 meter. So right now this is a very, very big simulation that we are simulating, and it might not be realistic if you're trying to do something like a coffee cup. You might want to size down the actual size of the domain. Next we have fluid boundary. Let's see. The slip, you should keep it like that. But yeah, there's nothing much on this side, but here is something really interesting. You have subdivisions, and if you increase this and you increase the tracer particle amount, maybe you should keep the subdivisions at like 2 or something, and put the generate up, like 0.3 or something. Basically what that does is makes it so that instead of having one little glob of fluid that always flies through the air, that one glob of fluid will, like in real life, it will split into other little pieces of fluid, and it will give you a lot more realistic results. It will look very good. But just remember that it's going to take a lot of time to do this, to render that. So I recommend, keeping it somewhat low. yeah, see, warning, can lead to longer computing time. So, yeah, just keep that in mind. Okay, that's basically everything with the domain. Let's go into our inflow object. So we have here a cube that if we enable fluid on it, and we set the type to inflow, we see these settings here, and we see the initial velocity on the x, y, and z axis. You can guess what that is. If we want our fluid to shoot this way, we want our initial velocity to be on the negative x-axis, so we'll put like -2 or something like that, or that's going to be a lot, -1, and we also want it to shoot on the y-axis, so like -1, and then z-axis like 0.5. Okay, so it will shoot like that, and like that. Okay, but then, that's cool and all, but you see here we have this option, export animated mesh and local coordinates. So basically what each of those will do is if you enable export animated mesh, you're basically going to be able to use this object as an animated object. So you can move it, you could have a moving inflow object, which is cool. But you also have local coordinates, so that basically if you, let's see, right now, this is my z-axis. But if I rotate this using local coordinates, this will now be my z-axis. So instead of, well, I'm sorry, if you wanted to always have it squirting out of this face, but it's rotating, that would be a very useful thing to use, local coordinates. Anyways, next we're going to add in a, let's see, we'll add in a UV sphere. And this will be our collision object. Okay, and so we'll enable fluid and obstacle. And basically, if you enable both, that will basically, well, that will make it better in a way. It's just the type of collision that it has. And impact factor, the higher you put this, maybe you put it at like 2 or something. The higher you put it, the more it's going to, you know, move around. The fluid's going to react more when it hits it, which is cool. And slip amount, the lower you put this, the more it will act like a slippery object. The higher you put it, the more the fluid will stick to the object. So that could be useful if you're doing something like chocolate or something, you want it to stick to the object, but if you're simulating oil, you're going to want no stick at all. Okay. That's pretty much it. I'm not going to go into outflow or control or particle, because those get kind of complicated. Fluid is something you should also look at. We won't use it, but it's basically the same as inflow, except that inflow constantly releases fluid, but a fluid object will basically act like a ball of fluid, if that makes sense. It'll, like, you've seen videos on YouTube where, like, this cube, well, actually, this is an example. This cube right here is a fluid object that basically falls, and that's it. But with this fluid, it'll act like a pipe that is always squirting water out. But I'm going on, and I should really get going on this baking. So, before we go baking, we have to set this temp cache, as I was discussing before, because if you don't, it's going to bake it to your temp. So we gotta we have to make the output a folder that we don't mind all the files being in. So I have a fluid sim folder. I'll make a new folder for my thing so that all my files will be inside of it. Cause there'll be like 250 files that we don't want to have just cluttering our folder. I'll name this fluid tutorial, and make sure you click on it, accept. And basically that's all. I'm going to set my resolution at 85, okay? It'll take me longer to render, but it'll be worth it. I'm not going to set it super high. Go on YouTube and look up Blender Fluid Sim High Res if you want to see some high res Fluid Sim, but it's not necessary to have it for this tutorial. I'm also in a hurry. I have to be somewhere soon, so yeah, we'll just keep it at 85 so that I can, yeah. Okay, so I'm going to pause the video while it's baking. This will take around 15 minutes, I don't know. fake. Okay, and welcome back. And I have, after about, I don't know, 10 minutes of rendering, around 50 so frames. And you can see that we have our water coming out inside the wall and colliding with this collision object. But you can see that it looks very, very low resolution. That's only because my preview is set to almost half of what the final, or more than half of what the final resolution is. So don't worry, when you render it, it's going to look twice as good if you set the resolution to the same thing I did. So yeah, so there are a few things we can do. If you're not going to use your cube anymore, and you don't want to render it, obviously, press M, move to layer 2, and you'll see that we have like kind of the outline of the cube, but it's not there. We're going to keep this collision object though in the render. We're going to smooth it though, so it looks a little better. And one thing we're going to do, Shift C to center the cursor, by the way, add in a plane. This will be our ground plane when we render it. So I guess now is the part where I get into the complicated process, actually not so complicated process of rendering out this fine image we have here. So first we're going to set up a camera angle that looks nice. I think this angle I have, yeah, this angle right here is pretty good. You can see the action pretty good. So once you scrolled around with your middle mouse button and you find a good angle, you could try to copy that with the camera by moving it around, but a really easy shortcut is to press Ctrl-Alt-0. Press 0 on your numpad. If you don't have that, I believe there is a view. Let's see, do cameras? No. Yes, here we go. It will be, so say my camera was over here and rotated weird. I had it like this. I do view, align active camera to view, and it's the same exact thing. So you don't have to have a numpad. But it looks like we're a little too far panned down, so we're going to rotate on the local x-axis, so that's the global x-axis. But if you press X again, so RXX, you rotate on the camera's x-axis, so we'll be able to move it like that, drag it down, maybe rotate it a little bit more so we don't get the edge of the plane there, and that's good. So next let's add our material for our plane, for our fluid. But we're not going to do this in Blender, because in Cycles, it is now very easy to get water. Well, actually it always was in Cycles, but you get a lot more realistic results. So we're going to select our fluid, we're going to add a new material, well it already does for you, make it fluid, name it fluid, and press use nodes, and we're going to show the preview too. So under surface, click that and make it glass. And basically, all you have to do is set the IOR value to the IOR value for fluid, which I happen to know as 1.333, and you will get that. And basically, that's all you have to do. You could change the color to maybe a hint of blue, but again, that's not very realistic. Most water is exactly pure white. It's only reflecting the colors around it. So make it pure white. And yeah, that's really all you gotta do for the material for the water. Of course, if you wanted to, you can make it purple Kool-Aid or something, but we're not gonna do that in this tutorial because we're just doing pure white. Okay, so next thing we can do is smooth our fluid. So just shading, smooth. That'll make it look like that, which kind of looks like crap. First we should save it though, so Control-S save. And if you were to render this right now, it would look very bad because there is no good lighting in our scene. So let's delete this lamp because we're not going to use lamps. We're going to use emission planes. So I'm just adding in a plane and moving it around, and we're going to make it so that it points at our object by rotating it a bit, and add a new material and make it emission, and have it emit white light, and have it at a strength of 3. Now in top view, we're just going to duplicate this with Shift D, duplicate it like 3 times. That will give us plenty of light in our scene. And the cool thing is that our world is a little dark gray, and that will give us some cool little caustic effects for the water, so we're not going to change anything about the world. You could get some cool effects if you change the background color of your world, just so you know. Okay, now I could add in a Subsurf Modifier now, but I don't know if I'm going to do that, because I'm not sure how high-res it looks in the final render. So, before I do that, let's just render it out. So, press F12. Make sure your F-lock is off. You'll see that it's looking pretty cool and pretty grainy, and it is also looking a lot more higher res than our preview. It has these little particles right here. These are the tracer particles that we made earlier. The little dots kind of floating around there. But you can see that if we wanted to get a better render, we would have to turn up the samples a lot more. So let's go ahead and do that, because right now we can't even tell it's fluid really, what's in there. But it looks like I'm not gonna have to add in a Subsurf modifier. Everything looks pretty smooth. In fact, sometimes that makes things look kind of blocky. So under the render settings, under sampling, increase the render to about 30, maybe? That might look good. So you might be wondering why I'm not doing the preview render. And that's simply because I would be seeing this resolution. And I'm not really concerned about that right now. I know my material and my lighting is good, so I don't have to check with that to make sure my material is fine. Because you can see everything looks fine and dandy. All that's needed is just more rendering. And actually, it might be a little too dark, so let's increase the color of our sky to a brighter color. That will, brighten our scene up altogether. Yeah, that's a lot better. And maybe, you know what? I'm gonna go crazy. I'm gonna give us some purple Kool-Aid. I've been thinking about it. I really like purple Kool-Aid, so we're gonna do that. Okay. Ooh, what happened? Okay, save. Alright, so now with our resolution set higher, we are going to render this out. And it should look substantially better, I hope. So yeah, let me just pause. I noticed that even with that, it's not set high enough, so I'm going to increase the render samples to 75. So this is going to take a long time to render, but I think it'll work out. I'm going to increase on the emission, on the this emission material that we made for our planes. I'm going to move them closer, and 2, I'm going to increase the emission value to around 5 to try to get some more light on this. And also on our sphere right here, we're going to add a new material and make it darker so that we can tell that there's an object in the middle of our crazy fluid scene. Okay, so let me actually, I'm going to turn down the resolution of my final render. That will speed up things a lot. And now let me go ahead and render. Alright, and that's that. So you can see here that my color is a bit lighter. I found that my color was too dark and a lot of the details weren't getting through. So if you're going to make a colored water, or if you're going to make colored water, I recommend you stay in this general circle here. So, don't get it too down here, or else a lot of the, detail that you made will be gone. So leave it like that. Now, obviously, I'm going to have to if I were to render out this animation, I would have to use a lot more samples and use a lot more render time. But you get the idea. This frame took about, well, it took a minute and 40 seconds to render. At 150 seconds, it might be around, at 150 render samples, it might take around 3 minutes a frame to render. So, you know, pretty render heavy, but, you know, in the end it's worth it, and you can get some really cool looking renders from using Fluid Sims. So, thank you for watching this tutorial. I hope you learned something, and if you haven't already, please subscribe. Thank you again.